guess we'll get started then, if everyone can see the screen as well. So this week it's another sort of, I mean, in normal times it would have been an in-class assignment, so it's really just important to sort of have a good attempt at each question and submit that, and if you do that, I'll give you full marks. So it's a pretty easy full marks, I guess. But I'll go over some similar problems. So, oh, there we go. Okay. So the first question I'm looking at, I'm going to just compute the integral, and then I'm going to think about sort of, I'm going to interpret the limits, and I'll from those limits I'll be able to think about the region we're integrating over, and then I'll reverse the order of integration and compute it again, and you should always get the same. You'll get the same answer, so that's some check, I guess, that you've done it correctly. So first, I'm integrating with respect to y from 0 to 4 minus 2x. So the first term, x squared, doesn't have any y, so we just add the constant y. And then the next term is y, so it's, if we integrate, we get y squared over 2. And that's from 0 to 4 minus 2x. So from that, first I sub in 4 minus 2x everywhere I see a y, so I get x squared 4 minus 2x plus half 4 minus 2x all squared, and then we minus and sub in zeros, and so for both terms, if you sub in a 0 for y, you're going to get 0. So and so then to integrate, it's easy sort of if I just expand and simplify. So we get 4x squared minus 2x cubed plus half. So 4 by 4, 16. 4 by minus 2x, but we'll get 2 lots of those. We get minus 16x, and then square minus 2x squared, so that's plus 4x squared. And then if we collect the collect the powers of x, we get 6x squared minus 2x cubed plus 8 minus 8x dx. And now we want to integrate with respect to x. So x3, we get a factor of 2 there, minus x to the 4, we get 2, plus 8x minus x squared 4. And that's from 0 to from x equals 0 to x equals 2. So if we sub in 2, we get 16 minus 8 plus 16 minus 16 minus 0 plus 0 minus 0 plus 0. So we get the answer is 8. So were there any questions about that first part yet? So now the question asks us to we're going to draw the region of integration, and then we'll be able to reverse the order of integration. So we can interpret the region from the limits. So we had that x was between 0 and 2, and y was between 0 and y is equal to 4 minus 2x. So if we draw that, so this is the line y equals 4 minus 2x. And now that can also be written as x equals 4 minus y all on 2. This is the point 0, 4. This line along the x-axis here is y equals to 0. This line here is x is equal to 0. This point here is the point 2, 0. And obviously this is the origin as well. So in that the first time we did it, we integrated y from y equals 0 up to this line here, and then we integrated x from 0 to 2. But when we reverse it, we're going to integrate x from x equals 0 up to the line x equals 4 minus y on 2, and then we're going to integrate y from 0 to 4 because we found the intercept there. Does that make sense to everyone? So if I write that down, so the integral becomes, so y is from 0 to 4, and x is equal to, from 0, we're going to integrate over 0 to 4 minus y all on 2. We're still integrating x squared plus y, but now it's dx dy. And then, we can just compute the integral again. So the region of integration is everything inside this triangle that I'm highlighting in yellow here. That's the region of integration. Cool. Now, again, I just need to sort of, the easiest way to do this is, I guess, expand and simplify. I'm not going to go through that, the expansion, but I expanded it, I simplified it, and I found that I got 1 on 24 over by 64 minus y cubed dy. And then I've taken the 1 on 24 out the front, so I get 64y minus y to the 4th on 4 from 0 to 4. And then if I compute that at the limits, I get 64 by 4 minus 4 to the 4 on 4 minus 0 plus 0. And if I sub all those numbers in, I get 8, which is what I got before, which is what you want. What's what we expect. So if you're not getting the same answer, you know that you've done something wrong, and I'd try and work out where you've made your mistake. I've got yeah, these are sort of functions of just x and y. So you can, I think we'll even do some later in this tutorial. We're looking at sort of integrating over 3D regions, but in this case we've only got x and y, so it's just an area of integration rather than a volume. Does that make sense? And so in this case, we've actually got 2 integrals that and so the integral we want to solve, so the first one, we're integrating first with respect to y, 2y, so we get y squared, and we're integrating that from 0 to root x, and we still have to integrate with respect to x. And then the next one, so we get the same, just the y squared here, but this time it's from x minus 1 to root x dx. So if we sub in the square root of x into where y squared is, we just get x minus 0 dx plus x minus 1 squared dx. And then we integrate with respect to x, so we get x squared on 2 from 0 to 1 plus so this becomes if we expand and simplify, we get 3x minus x squared minus 1 dx. So here we get half minus 0 plus 3x squared on 2 minus x cubed on 3 minus x from 1 to 3 plus the square root of 5 all on 2. And you'll see what that sort of comes from in a moment. And then if we just sub in ones here, we get minus 3 on 2, minus minus, so plus 1 on 3, minus minus plus 1. And if I substitute all of those in and simplified, I find I get 13 on 12 plus 5 on 12 root 5. And I don't think yours are as messy as that, so that's nice for you. And so now we want to do the same again. We want to interpret where the region is, given the limits. So in this one, we had, so x was going from 0 to 1, and y was going from y equals 0 to y equals the square root of x. And then for the second part, we had that x was going from 1 to this 3 plus root 5 on 2, and y was equal to x minus 1, and then rather than the y equals 0, and then y equals same root x. So y equals root x, that's equivalent to x equals y squared, and y equals x minus 1, get x equals y plus 1. And I'm also going to note that solving which part did you want to look at? Does that help? So if we solve the square root of x is equal to x minus 1, that gives that 0 is equal to x squared minus 3x plus 1. So if we solve for x using the quadratic formula, we get 3 plus or minus root 5 on 2. And so that's where this limit has come from, where those two lines intersect. So now if I draw this, so this is the line y is equal to root x, and then this is the line, the linear line, y is equal to x minus 1. And so this point here, that's that 3 plus, obviously not minus is here. That intersection would be over there somewhere. 2, and then 1 plus root 5. So that's the y value. And I've just found that by either going y is equal to the square root of x or y is equal to x minus 1. They will give you the same answer because it's the intersection of those two lines. And so That's the 0.10. So the way that the question had it set up, it had this was region 1 and this was region 2. So, because this is the line y equals 0, so in this region, we're going from y equals 0 to y is equal to the square root of x, and x is going from 0 here to 1. So that's the region 1. But our region 2 is no longer bounded by y equals 0. It's bounded by this linear line here, y equals x minus 1. And so we integrate from that to y equals the square root of x. And then x, we're integrating from, so x is equal to 1 here, all the way to x is equal to this number here, 3 plus square root of 5 all over 2. So then that's your region 2. But if we reverse the order of integration, we actually only need, we only have one region now, because we're going to integrate from x equals y squared, because this can also be given as, this is also equal x equals to y squared, and this line is also x is equal to y plus 1. And so we're going to integrate from x is equal to y squared all the way to x is equal to y plus 1. And we can do that from y is equal to 0 to y is equal to this number here, where the lines intersect. Does that make sense to everyone? And can you see that now we only need one region? So if I write the integral, so y is going to go from y equals 0 to that 1 plus the square root of 5 all over 2. And then x is going to go from y squared to y plus 1. We're still integrating to y, but now we're going dx dy. So we can just take that 2y, because at the moment that 2y we're treating as a constant. So we can take that out the front. So we just get the x. And our x is going from y squared to y plus 1 dy. So that's y plus 1 minus y squared dy. Or if we expand that, we get 2y plus 2y squared minus 2y cubed dy. And then polynomials are pretty easy to integrate, so we get y squared plus 2y cubed on 3 minus y4 on 2. And then we just have to sub in those limits again, as we've been doing. And if I, I guess expand all of those and simplify, I get that 1312 plus 512 the square root of 5, which is the answer I had before. So again, we know that we must have done something right if we're getting the same answer as expected. Does anyone have any questions about that at all? I'm not going to do a question that's sort of similar to question 2 in your assignment, because it's pretty much more of the same. You've got integrals, and then they're asking you to draw the region, reverse the order. It's the same thing. If you draw a picture and sort of think about the regions you're integrating over, it's they're not that different from each other. So does anyone have any questions, or shall I move on? Okay. I'll move on to question 3. So, I mean, it's pretty much more of the same anyway. We're going to evaluate. We're going to integrate over the region D, where D is the negative quadrant of the unit circle, and the function we're going to be integrating is xy squared. So D, the region, is it's the negative quadrant of the unit circle we're looking at. So it's x is going to be less than 0, y is also going to be less than 0, and x squared plus y squared is going to be less than or equal to 1, because it's the unit circle, so the radius is equal to 1. So, I mean, if I draw that, so this is y is equal to 0, this is x is equal to 0, and this line here is x squared plus y squared is equal to 1. So we either get x is equal to minus 1 minus y squared, because we're in the negative quadrant, or y is equal to minus 1 minus x squared. And then, this is our region D. Does that make sense to everyone? And so now I've chosen, so we've got, it wants you to do dx dy. So y is on the outside. So y, we're going to integrate from y is equal to minus 1 to y is equal to 0. So that's from down here to up. We're going that way. And on and x, we're going to be integrating from this curved line here, which is x is equal to minus the square root of 1 minus y squared, to x is equal to 0, which is this line here. And the function was x y squared dx dy. So I just took the y squared out there. Because we're just integrating with respect to x first, and y squared has nothing to do with x. It's just a constant. We can treat it as a constant at the moment. So I get x squared on 2, but I decided to take the factor of half out the front. So I get y squared by 0 minus 1 minus y squared all squared dy. So I'll take this minus out the front. This minus becomes positive 1. Minus 1 squared is just 1. And so I get y squared by 1 minus y squared dy. So that's y squared minus y to the 4th dy. And again, it's just integrating polynomials, so y to the 3 on 3 minus y to the 5 on 5 from minus 1 to 0. So we get 0 minus 0 minus 1 to the cubed on 3 minus 1 to the 5 on 5. So I get plus a third minus a fifth. So I get minus 1 on 15. Did anyone have any questions about that one? No? So I'm not going to do another one. But I will now rewrite that integral using cylindrical coordinates, then compute the integral. So obviously, when you look at it, it's a quarter of a circle. Cartesian coordinates, I guess, doesn't lend itself as well as if we were going to use cylindrical coordinates. So in cylindrical coordinates, that same region, we have rho and phi. So rho is going to go from 0 to 1, and phi, so we're in the negative quadrant here, so phi is going to go from pi, because we've got if phi is equal to 0, phi is equal to pi on 2, phi is equal to pi, and phi is equal to 3 pi on 2. So we're looking at this angle of phi through here. So we're going from pi to 3 pi on 2 there. So if I look at that in the diagram, phi is equal to, rho is equal to 1 here. Phi is equal to pi. This is phi is equal to 3 pi on 2. And that's that same region, D. And we also need to change that turn this xy squared we need to change this xy squared to be in cylindrical coordinates as well. So if you'll recall that x is equal to rho cos phi, y is equal to rho sine phi. And so in cylindrical coordinates, so z here is actually, we're just in a plane of z, so z is a constant here. So we get that dA is going to be equal to rho d rho d phi here. So that's what we replace sort of the dx dy with. Does that make sense? And then your function of x and y is equal to y squared x is now equal to f, a function of rho and phi is going to be equal to and in my case, I'm just going to leave that as is, but sometimes it is useful to use like double angle formulas and the like to make integrating easier. So now we have the integral. We've got phi, we're going from pi to 3 pi on 2, and then rho is equal to going from 0 to 1. So now we no longer have sort of that, in this case, we had y in the limits when we were integrating with respect to x. But we've removed that here. Don't forget this extra rho term here. And so because there's no sort of rhos or phis in the limits, we can actually just calculate them completely separately. So we get, we want to integrate rho to the 4 from rho equals 0 to rho equals 1, and we also want to integrate sine squared by cos phi d phi. Does anyone have any questions about this so far? So, just another polynomial. It's pretty easy. And then in my case, we can see that sine squared phi cos phi is, if we integrate it, it's sine cubed over 3. And you can see that, like, if I try and differentiate that, I need to use the chain rule, so I get 3 sine squared phi on 3. The 3's cancels, but then I have to also integrate sine phi with respect to phi, and so then that's just cos phi. So I get the same. So I've taken that factor of 3 at 1/3 out the front. I get 1/5 minus 0 for that one. And then I get sine cubed 3 pi on 2 minus sine cubed pi. So I get the 1 on 15 by minus 1 cubed minus 0. So I get minus 1 on 15 as before. So again, we've sort of played around with the integral. We've written it using other variables, but we're still getting the same answer. So if you find you're not getting the same answer for any of them, you know you've done something wrong, and you should look at it further to see where your error is. Okay, so question 5. I guess if you can pretend that this top part is cut out so that we just get this wavy cylinder type thing. This surface here is the surface area that I'm looking at. And that's the surface area of this cylinder with the wavy ends is the surface area that I want to find. So in cylindrical coordinates, the surface area, we'll give that by SA. So we're going to do double integrate over that region, and the region is given by so our radius is so this is just sort of, I guess, regular cylindrical coordinates, and then I'll give the conditions that are applied in this case. So we have that the radius is equal to 1. The walls are, oh sorry, that should be a row there because we're in cylindrical coordinates. We've gone all the way around the cylinder, so the phi is just sort of what it normally is. And the z is going to go between, so the two wavy ends, z is given by 1 plus 1 on 10 cos 16 phi, and it goes all the way up to z, 2 plus 1 on 10 16 phi. So since rho is constant here, we have and obviously that row there is going to be 1 ultimately. So our surface area is given by, so phi is going to go from 0 to phi is equal to 2 pi. And then z is going to go from 1 plus 1 on 10 cos 16 phi to z is equal to 2 plus 1 on 10 cos